Good morning, everyone. How's everybody doing today? Enjoying reInvent? Yes. Amazing. Wow. So, welcome to CON327, serving 4.8 billion railway customers a year, the story of Deutsche Bahn. I'm super excited about being here in person at reInvent this year, and I think we have a fantastic story for you. My name is Sascha Möllering, and I'm an AWS Specialist Solutions Architect for containers. And together with my colleagues, we are supporting our customers in Germany, Austria, and Switzerland. And one of our customers we support is Deutsche Bahn. Unfortunately, Ralf Gernholz, the CTO of Deutsche Bahn Vertrieb, had travel-related issues and can't be here today. Ralf was really looking forward to being able to deliver this talk this year at the reInvent, and he's really sorry about this. So, if you want to learn about modernizing applications with containers, what exactly Deutsche Bahn has accomplished and what our journey together was like, then you're at the right place at CON327. So let's start with the agenda for today's session. I want first to talk about application modernization in general and why this is important and which challenges our customers are facing. And in the next part, I'm going to cover the transformation of Deutsche Bahn and share details and insights about a specific project called Vando. And then we'll have a closer look at Vando's technical implementation. And we've picked some very interesting use cases, which give you some insights about those particular use cases from an architectural perspective. And then the last part of the session, I'm going to talk about some of the key takeaways and some challenges that Deutsche Bahn has faced and which technical optimizations they're going to implement for Vando in the future. But before we get into that, I'd first like to talk about the typical challenges customers are facing when modernizing applications. So, one of the most important questions customers are asking us is, why is application modernization actually important and which impact does it have if I optimize or if I modernize my applications? So, and based on a study from Deloitte, CIOs tell us that most IT organizations are still dedicating the majority of their IT resources in keeping the lights on. So 80% of developers' time is spent on operations and maintenance, and only 20% is spent on innovation. And of course, CIOs would like to reverse that ratio. And one way to achieve this is by building modern applications in order to build new customer experiences. So, and when we talk about keeping the lights on, we have to think about legacy development culture and the symptoms of legacy development culture. What we typically see when we speak with customers is that they have long release cycles for new products and features, operational inefficiencies and high overheads in people and hardware, and an inability to address security imperatives or regulatory concerns. And of course, this has a severe impact on the business. Of course, if you have long release cycles for your products and for your features, you have lost revenue due to missed opportunity and loss of competitive edge. Similar for operational inefficiencies. Those result in overhead of costs, which means you have lost productivity or high costs for your undifferentiated skills. And even worse, maybe the inability to support changing compliance and security regulations. This could lead to fines for non-compliance, reputational impact, and lost customer trust. So, what do our most successful customers want from us? What lets them innovate quickly, compete in a global market, and deliver value for their customers? Well, they want their teams to deliver products to customers as fast as possible. Right? So, which means getting to market faster, reduce time to market. And they want their applications and infrastructure to be reliable, highly available, and scalable. And of course, combined with the highest level of security and isolation. And they want this all with a lower total cost of ownership. And when we think about building modern applications, so one of the things that instantly comes into mind is, of course, speed and agility. So agility is key because it enables you to experiment, and this is really important. So your developers can just change a couple of lines of code in your application, roll this out to production, measure the impact of this small change, and if it didn't work as expected, they can easily roll back. So However, Big Bang releases are a completely different story. So Big Bang releases are always a huge risk because you have to change a lot in your application, which means maybe you change thousands of lines of code, a lot of new dependencies, maybe a library version has been updated, APIs have changed, and so on and so on. And if you accumulate all those changes and then do a Big Bang release, then the risk that something is getting wrong is really, really high, because you have to test extensively. And even if you automate your complete tests, then somehow, maybe, sometimes you might run into issues. Small releases are basically a risk management for your software development process. But as we have seen, most of the time is still spent keeping the lights on, so focus should be to spend more time writing the actual business code that makes a difference and less time managing infrastructure. And from a security and operational resilience perspective, it is super important to build security into the infrastructure, into your application, not as the last step, but as a core feature of your infrastructure directly from the beginning. One example with AWS Fargate, which is a serverless pay-as-you-go compute engine that lets you focus on building applications without managing the servers. You have container isolation, which is a core feature. So each Fargate task or pod has its own isolation boundary and does not share underlying resources like, let's say, the kernel, CPU resources, memory resources, and so on with other tasks and other pods. And from a cost perspective, ask yourself, how often did you experience a project being delayed since it didn't have the resources to get started? Cloud reduces the overall activation energy, so you can start small, you can scale up your experiments, and in addition with managed services, you don't have to invest in setting up and maintaining complex infrastructure, like, let's say, Kafka clusters, for instance. So you have a lower activation barrier, and you spend less money. So, and how do you know that you have arrived, that your modernization journey was successful? What does good look like, and what are the indicators that your efforts will pay off and the business will benefit? So here are some common challenges that you see and the outcomes experienced by our customers during their modernization journey. So we can automate away tedious work and deliver fast. So deploys go from days or even weeks to minutes, meaning the time to market is shortened. And we can remove the overhead by using consistent tooling and processes to do more than just keeping the lights on, right? So deploys are no longer manual, which means you can experiment more often, you change just a couple of lines of code, deploy it, see if it's working or not, so you have more agility. And we can build security into software development processes and operational activities. So it's not longer bolted on as an afterthought, so to say. So your security footprint basically follows best practices. So it's no longer ad hoc, and the management overhead shrinks. And what is really important for a lot of customers is having the visibility in what is actually going on in production. So developers should have full visibility into the application and then can contribute to its evolution proactively. So observability is a super important topic here. Let's imagine you have your workload running in production and something goes completely wrong, and it's a complex microservices architecture with like synchronous communication, asynchronous communication. You maybe have databases, you have queues, and so on. And then with standard tools, try to find what was going wrong. This is super complex. If you have complete traces of what is going on in your application and in your architecture, then things are much, much easier. So part of the reason this level of organizational change is now available is due to the evolution of compute technology. So in recent years, compute has undergone a, let's say, profound paradigm shift from to containers and serverless as companies seek deeper agility and efficiencies for their operations. And as this graph indicates, we all began with physical machines where the ability to scale and to be agile and to innovate was somewhat limited. And so gradually, we introduced things like virtualization, so Amazon EC2 instances, which brought faster speed and agility and also reduced maintenance and scale. And the third wave is containers, which gives you a high degree of mobility. Agility became a super important topic here, and you have benefits like the platform independence and fast deploys. So let's say you're running a workload on-prem, and you want to quickly move this to the cloud. So one option, of course, would be to put those applications into a container and shift it into an ECS or Kubernetes cluster. So because container allow you to package your application and all the dependencies and move them between different computing environments. And of course, there is serverless, where you don't have to care about any of that. So back from the beginning, we are really witnessing a paradigm shift. And this is driven by our customers working backwards from what they need to do to win the market. So customers, obviously, want to win more customers. And to win more customers, they need to build better products. And to do so, they need to innovate more often. And this means release features faster. So they need the ability to focus on differentiating business logic. And one of the things that can help is decouple the existing software systems. So now I want to dive a little bit deeper into the modernization of Deutsche Bahn and how our customer has implemented his transformation with Vando, its digitization program. So Deutsche Bahn, if you don't know, takes responsibility for the daily transport of millions of people in Germany every day. So to get to work, to see your family, to go on vacation, to see friends, and so on. And just to remind you, in the infrastructure and transport industries, there are only three things that count. It's reliability, reliability, and of course, reliability. So when we take a closer look at Deutsche Bahn Vertrieb, they have the central responsibility for the sales of Deutsche Bahn Personenverkehr products. And Ralf Gernoldt is the CTO of Deutsche Bahn Vertrieb and the program director for Vando. When we take a closer look at the portfolio of Deutsche Bahn Vertrieb, we see that they have travel centers. So those are basically physical service centers where you can go, you can buy a ticket, you can get information for a specific route if you want to travel from city A to city B, and you can get any help you want. Then there is, of course, an e-commerce website in the internet where you can buy your tickets, buy subscriptions, and so on. Same also applies for a mobile application, so which means you can have your ticket on your mobile device, and then you can automatically check in if you get in the train and so on. And of course, there are still vending machines. So let's say you fly to Germany, Munich airport, and you want to go to the city center. So one of those things that you see are a couple of vending machines where you can basically buy a ticket and drive to your hotel. And different end customers of Deutsche Bahn have different requirements. So for instance, there are customers that buy a subscription using an app or a vending machine for when you just landed at an airport in Germany and want to travel further by train. And approximately 10% of the around 18 million Germans use their services daily. And every customer group has different urgencies. So maybe you need to catch a train. So it's really important that the ticket printer is fast. Or to find a super cost-efficient solution to get from Munich to Hanover. And they cater everybody. So from senior citizens getting their tickets printed out by a sales assistant in the service center on the stations, paying cash, to students that are just using the mobile application. And let me put this into an even bigger economical perspective. So these urgencies do not just concern people transport, but the reliable transport of goods, as well as, of course, the railroad network itself. So as you can see in those quite impressive numbers, this is a huge routine that needs to be managed, monitored, and kept afloat on a daily basis. It has to be hassle and friction-free. So, I mean, we have over 7.3 million customers across Germany per day. We have over 1 million tons of goods transported per day throughout Germany and Europe. And we have over 40,000 trains traveling daily. So this is a huge responsibility, of course. If Deutsche Bahn doesn't function properly, if they are unreliable or too late, then Germany and the German economy doesn't work properly anymore. So, and you can imagine that this is seen as a catastrophe in an engineering-driven country like Germany. And to make that operation possible, their customers need to have access to their sales platform first and all the time. And here the end customers and Deutsche Bahn experience a huge, let's say, roadblock on the rails. And this is legacy IT and the need for renewal. So their IT systems are shaped by a time when tickets were sold over the counter mostly and were paid cash. So Deutsche Bahn has to deal with a 40-year-old technological system that has long adjustment times, super high test efforts, and even higher cost of implementation and maintenance of the systems. And this is why the interface of a typical vending machine looks so complicated when you just want to try to buy a ticket quickly and seamlessly, because you have 40 years of business rules implemented there. So I hope you feel the weight on their shoulders a bit. And they had to tackle all those very diverse challenges and integrate all the different systems. So we have online, we have offline, we have mobile, and so on. And a ticket and information center at a station should give an end customer the same service experience as using the app. So this way they could make the sales process integrated, seamless, and also future-proof. And now I want to take a closer look at the new sales platform to ensure the digital future of Deutsche Bahn Personenverkehr. So what we immediately see is that there are different touch points. We have the travel centers, we have the vending machines, partner sales channels, we have an online platform, and we have the Deutsche Bahn Navigator app. And this is a more complex process than it looks on the slide behind me. So all these steps have their own rules, processes, and of course obstacles. So the goal was basically to implement an agile delivery approach with more than 500 project participants and approximately 1.6 million lines of code. So Deutsche Bahn has implemented a fully automated delivery process using a CI/CD chain. And again, what was really important was that this platform was built cloud native, with the goal of having highest availability, automatic scalability, and consistent performance. When you take a closer look at the touch points, you can see that they're accessing different business domains. So we have, for instance, things like identity management, the data lake, inventory, the booking system, and we'll take a closer look at the reservation system in a couple of minutes and how this is technically implemented, because this is from a security and also from a networking perspective a very interesting use case. So we see everything is basically abstracted using a common business service API. So, and Vando is basically the backbone for Deutsche Bahn's strategic growth initiative Starke Schiene, which means strong railroad. And Vando is an integrated sales system and used as the backbone for it. So, and it integrates 4 different pillars that will enable a seamless digital experience for their customers. So, first pillar is time to market, then there's omnichannel, cloud, and UX. And Deutsche Bahn wants people to take the train more often and with pleasure. And of course, this is only possible when they trust the experience they have with the system. So that means that they have to give their customers a seamless and reliable travel experience. And through the use of modular microservices architecture, they have shortened the innovation cycles here. And the time to market experience will enhance by 5. And this is really impressive. Currently, Deutsche Bahn deploys 54 times a day. So whenever software is ready, it is pushed to production. And by achieving that, they'll see that quantum leap in user experience. And the true omni-channel strategy they set out starts with an interface that is easy to recognize and seamless to use and operate on all platforms. So the goal is ultimately to have this consistent user experience, which is the goal of all of their efforts. So, and the first step to achieve that goal was already taken in 2016. And Christa Könen, their CIO, announced the cloud-first strategy. So, and then the first step in this strategy was basically a lift and shift approach. So all existing Deutsche Bahn workloads and the apps have been shifted to the cloud, and Deutsche Bahn started selling the data centers. And now they've adopted a cloud-native approach, so new applications are built using cloud-native approach, and workloads get containerized, which means there's a new way for Deutsche Bahn of operating their IT. And for the development teams, this was really important because with the cloud trust, so with the usage came experience, and with experience come trust, which means trying even more in new services. So we've taken a closer look at the transformation of Deutsche Bahn and Vando related details. Now I want to dive a little bit deeper into the technical implementation. So just to quickly repeat this, the goal was basically to rebuild IT systems for an improved user experience and reduce time to market. And initially it started with a domain-driven design approach with microservices and open source software. So it was a very developer-driven approach in the beginning. And from a technical perspective, the key goals were scalability, flexibility, and reduced operational overhead. And this is why Deutsche Bahn decided to use Kubernetes and Amazon EKS as basically the base for all of their workloads in the Vando project. And I want to quickly recap a couple of core concepts. So not too much, because this is not an introductory session. Just want to get just want to bring everyone on the same page. So when you set up an EKS cluster, what you see is we have a control plane and we have a data plane. And you, the customer, interacts with the Kubernetes API using a tool such as kubectl, could be also other tools. And the control plane is fully managed by AWS. And it is also deployed in its own AWS VPC. And then we basically have two different options when it comes to compute, where you actually run your workloads. So first of all, this is Amazon EC2 with the Amazon EKS managed node groups or self-managed nodes. And those EC2 instances are in your customer VPC, so you can see them in your AWS console, in your EC2 console, check all the CloudWatch metrics, and so on. And then, of course, there is a serverless option with AWS Fargate, which is also put into an AWS VPC. So this means we have here also cross-VPC and cross-account communication. And a typical EKS implementation is not isolated, but integrated with other AWS services. So what we see here is like a typical account that is used in the context of a Vando. So we have, of course, a dedicated AWS VPC that has the EKS control plane. And then we have the Deutsche Bahn VPC, which has the data plane with the EC2 instances. Could be self-managed, managed node groups. We've already covered this. And they are, of course, placed in different availability zones for high availability reasons. So, and for security reasons, it is recommended to place the EC2 instances in the private subnets of your VPC. And as already mentioned, EKS clusters usually aren't isolated, but communicate with other AWS services, because somewhere you have to store your state, right? So, and we've picked a couple of use cases which might be very interesting. And my personal use case I want to highlight here, the use case I really like is the usage of AWS KMS. And this is an interesting use case because it is used for the ticket check. Let's imagine you sit in a train. You have your train ticket on the smartphone, and this is basically a barcode, and this has to be checked because when someone comes and checks if your ticket is valid, and the barcode has to be created, and the keys which are necessary for that are stored in KMS. Different use case would be Amazon MQ. So this is used in various places. So for example, for real-time or near real-time information if there are, for instance, schedule changes. S3 is used in various places, of course, as a general data store for backups. And then it is also used as a cache to store requests for offerings. So if customers make a request for a particular route, let's say you go to the website and you want to travel from, I don't know, Munich to Hamburg, for instance. Then an offer is generated for this, and this is temporarily stored in an S3 bucket and can be reused. RDS is used as a general data store or as a general database for microservices, because the microservices are designed in a stateless way, which means they have to store data in an external system. And in this case, this is an RDS database, mostly Postgres. And now I want to dive a little bit deeper into the reservation system workload, which I've mentioned a couple of minutes ago. And this is especially interesting because it needs a connection to the corporate data center, because some parts of the reservation system are still running on-prem. And this is an AWS account in the region EU Central 1, so it's in Frankfurt. And of course, it has a VPC. And in this VPC, we can see two different sets of subnets. We have public subnets and we have private subnets. And the worker nodes of the EKS cluster are in a private subnet using an auto-scaling group. And in order to scale the compute infrastructure, the cluster autoscaler is used. So the Kubernetes cluster autoscaler, of course, automatically adjusts the number of nodes in your auto-scaling group so that all pods have a place to run and there are no unneeded nodes. And for this particular use case, it is important to have a connection to the reservation system that is running in the corporate data center. And in the routable subnet, we have a load balancer and a net gateway. And this is used to connect to the corporate data center in combination with direct connect and transit gateway. And so for inbound access, which means services which are connecting back, the load balancer is used. And as already mentioned, we need some kind of persistence for the data generated by the service running in EKS. And for this, RDS databases are used. Of course, RDS is also put into private subnets. A different use case is a data warehouse. If you have a complex system like this, of course, you generate a lot of data, and I mean a lot. So we have a very similar setup. So we have an AWS account in Frankfurt. We have a VPC with public and private subnets, but I've only listed here the private subnets because the public subnets are not very interesting. So we also see here our non-routable subnets with the EKS data plane, so the EC2 instances running. And on those EC2 instances, we have our services. And then we have a data lake, which is built using S3, Amazon RDS, and Amazon EMR with Spark. So what is happening here is on the EC2 instances, we have multiple services creating data constantly. So and this data is stored in an Amazon S3 bucket, and read by the Spark cluster, transformed, and then written in the RDS data warehouse. And of course, if we have a data warehouse, we want to have some kind of analytics. And this is done using EC2 instances running a data service for the analysis of the data. And of course, everything is in private subnets. So Deutsche Bahn is using Spot instances extensively. And currently, this is used in various environments, especially in development and test environments, especially to run load tests in order to reduce costs. So you can think of Spot instances as spare Amazon EC2 capacity. And this is basically the same infrastructure as on demand. And you save up to 90% compared to on-demand pricing. And Spot price is based on long-term supply and demand trends. And of course, Spot instances are interruptible, which means they can be interrupted by a 2-minute warning if Amazon EC2 needs a capacity back. So for many container workloads, this isn't a big issue because usually they should be designed in a way that it can be interrupted, like let's say a standard 12-factor application. So state needs to be saved in an external system. So this means Spot and containers are usually a pretty good match. And Deutsche Bahn uses the Spot instances also as an interesting architectural building block. So if you expect interruptions and have to handle them, this helps you to build resiliency. And now you can also test Spot interruptions using the AWS fault injection simulator. So you can do this from your EC2 console, which is super convenient. And previously, customers had to run Spot instances as self-managed worker nodes in their EKS clusters. So this meant doing some of the heavy lifting, such as building and maintaining configurations for the Spot instances in an EC2 autoscaling group, and also deploy tools for handling Spot interruptions gracefully, deploy AMI updates, updating the kubelet version, and so on and so on. Now all you need to do is to supply a single parameter to indicate that a managed node group should launch Spot instances and multiple instance types that would be used by the underlying EC2 autoscaling groups. Now, what is really important here is that we have a specific allocation strategy. This will be configured as capacity optimized. So what does this mean? This means every time the node group will scale, this could be your Kubernetes cluster autoscaler, increasing the node group size. This could be manual size increase or other automations you use. The instances will be launched from the most available capacity pool. And this works to decrease the number of Spot interruptions in your node group and increase the resiliency of the application. So how can you create a cluster with managed node groups? Well, here's an example that you can use with EKS CTL, which is a CLI for creating EKS clusters. So there are two different configurations we recommend our customers. There is an attribute-based configuration, and there's an instance type-based configuration. So let's start with the attribute-based configuration. This is where you basically provide your compute requirements, and an autoscaling group is created, which will then choose an instance which fall into the configured criteria. So in this particular use case, we have an instance selector and configured with 2 vCPUs and 2 GB of memory and CPU architecture x86. Pretty convenient. If you want to have more control over what is actually going on, then you can explicitly mention the instance types you want to use. And this is the instance type-based configuration. What you see here in the instance types config is we have M5X large, we have M5DX large, and we have M4X large. So why those instance types? Well, the cluster autoscaler makes a couple of assumptions. And one of those assumptions is that for all the capacity with a node group, to have instances with the same number of vCPUs and memory. And that's why it's configured that way. And in the future, Deutsche Bahn will also take a closer look into Graviton processors, which are custom AWS silicon with 64-bit ARM cores. So Graviton processors are basically designed by AWS to deliver the best price performance for your cloud workloads running on EC2. And this is basically targeted to reduce costs. And you have, of course, a range of instance types which you can choose and the same Nitro building blocks. Graviton 3 processors are the latest in the Graviton family, and they provide up to 25% better performance compared to Graviton 2 processors. And one very important fact here is also that they have the best performance per watt of energy use in Amazon EC2, which helps to reduce the carbon footprint. So when we talk about Graviton instances, of course, we also have to think about the instruction set that those instances are using, and this is basically an ARM instruction set. So if you have an x86 instruction set and an ARM instruction set, and you want to be flexible for your workloads, then you basically have to build a multi-architecture container image, which means you have to build a container image for x86, one for ARM64, and then a Docker manifest list. And a manifest list is basically a list of layers that is created by specifying one or more image names, which means you have this package of different container images, the manifest list, which you can all put into Amazon ECR, and then depending on the compute infrastructure you're using, like, I don't know, if you have specified your Fargate fleet with ARM64, then the correct container image is pulled from Amazon ECR. And with code pipeline and code build, you can automate the creation of architecture-specific container images, which can be pushed to ECR. So you can automate the whole orchestration of these projects using code pipeline. So we've taken a closer look at the technical implementation, and now we're coming to the end of the session, and I want to share a few key takeaways in Deutsche Bahn's future plans. So application modernization is basically a journey that impacts the whole business. So it's not just your development team, but the whole company is basically affected. And there is no hard rule about the right or wrong way to modernize. And it's important to remember that that one size does not fit all. So this means your modernization journey could be completely different compared to what we have seen today. And agility is key. Please embrace failing fast. Development is an iterative process, so write everything as code, and not only your application, but also your infrastructure. Also try out new technology in an agile way, which helps building trust in the organization, and it gives you confidence. Start small and scale your experiments. One of the results that can be achieved by application modernization is reduced time to market. So Deutsche Bahn is live. You can see the efforts of the Vando project. So there's nextbahn.de and also the new mobile application. And what we as AWS did together with Vando was a well-architected review. And we suggested potential improvements for the architecture. So the well-architected framework describes key concepts, design principles, and architectural best practices for designing and running your workloads in the cloud. So, and there are 6 different pillars. One of the areas we identified for potential optimization was backup and resiliency. And as already mentioned, the data is currently backup in one AWS region. Vando plans to implement a multi-region backup using S3 and for cold data Glacier. In addition, we also noticed that Deutsche Bahn can improve the resiliency of the workloads by cluster separation in order to reduce the blast radius if something goes wrong. Also, one of the things that we're taking a closer look in the future is this graceful degradation as a pattern. And in order to optimize for cost and resource usage, Deutsche Bahn plans to increase the cost transparency for each development team. Spot instances are already used for dev and test, and it's likely that this will be rolled out into production as well. And to optimize not only for cost, but also for carbon footprint, as already mentioned, Graviton is super interesting. So, and that's pretty much it. So my final words are to thank our customer Deutsche Bahn for sharing their experiences with us, and we look forward to continuing our work with Deutsche Bahn.